Hey everyone, welcome to my channel. Today we are going to create this waste classifier. So as you can see, when I use a card, you can see these cards that I have. When I put them in front of the webcam, it tells me what kind of waste bin should it go in. So we have residual waste, we have hazardous, we also have recyclable waste. So it will tell you which waste do you need to use. So this actually came with a game. It was a complete set. We have these different boxes, and in the future what we are going to do, we are also going to add a servo here with Arduino, and whenever we have the correct waste card, it will open up the correct waste bin. So that will be pretty amazing to see. But for today we are going to create this classifier. We are going to go step by step, and we will use the graphics as well. All of this will be available for free to download on our website. So here you can see the demo. This is the disinfectant, should go in the hazardous. These are vegetables, it should go in food. We have watercolor pen, it should be residual. We have the newspaper, we have old shoes, and then we have the battery. So we have a lot of different classes here, a lot of different objects, and we have a total of 4 classes. We are going to learn all of this, how to train the classifier, how to use it in Python, and how you can use these different images, these PNG images, to overlay and create this amazing graphics. So stay tuned, and we will go step by step so that it is beginner friendly and easy to follow. So let's get started. This video is sponsored by Brilliant.org. They provide online courses and practice problems in math, science, and engineering in a fun and interactive way. The courses are self-paced and cover a wide variety of topics from basic arithmetics to advanced calculus. The practice problems are designed to help students improve their problem-solving skills and prepare for exams. Brilliant bridges the gap between theory and practice, allowing you to visualize and apply what you learn. They have over 60 courses including Introduction to Neural Networks and Cryptocurrency. Click the link below to get started for free with Brilliant's interactive lessons. The first 200 listeners will also get 20% off of their annual membership. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CV Zone platform. Links are in the description. So without further ado, let's get started. So here we are in our PyCharm project, and the first thing we are going to do is we are going to remove all of the code, and as you can see we have a main.py file, and then we are going to install our packages. So we'll go to settings and project, trash classifier, we'll go to the interpreter, and we are going to add. So here we are going to add CV Zone, and we will also add TensorFlow. TensorFlow is required because when we extract the model, we are going to use TensorFlow to actually use it within our Python environment. So we will install TensorFlow. TensorFlow will take some time to install, so be patient. And this library causes a lot of problems as well, so make sure you see the specific version. So I'm using 2.1.01. I'm using Python 3.7, which is quite old, but it is stable. And then what about CV Zone? CV Zone, we are using 1.5.6, and these are all the rest. Now Opencv, the newer versions, they don't have autocomplete with PyCharm for some reason. So what you can do is, to fix that, you can double click on the version and you can specify a different version. So the one I have tested and works is 4.5.4.60. So this is the one that actually works well. So we can install that instead. Now CV Zone package will install Opencv for you. So that's why we had this. And now the installations are complete. We have successfully done TensorFlow and Opencv, the old version. So if I write import CV2, we can import CV Zone as well. We write CV2, and then we can check. Actually it's indexing right now, so we can wait a little bit to actually get the full functionality, but let's try. Maybe we have it. CV2 dot video capture, let's say. Yeah, so it's there. So what is the first step? before we actually start, let's have a look at the resources that we have. So we have a folder full of resources. Let's open that up, and actually let's open it up in the Explorer so we can really see what's going on inside using these gallery options. So here in the resources we have bins. We have a folder called bins, we have a folder called model, we have waste, we have an arrow image, and we have a background image. So let's start with the simple one. We have a background image. This is the main image. It's 1280 by 720. So we are going to take our webcam and we are going to place this webcam feed within our MacBook over here, or Mac. So here we are going to add that, and over here we are going to show the results. So for the results we will have bins. So which bin are we talking about? So is it recyclable, or is it hazardous waste, or is it food waste, or it is residual? So these are the 4 categories. You can add your own categories and you can have your own images, but these are the ones we are going to use, and you can download all of these for free through our website. All you have to do is sign in. If you haven't created an account, it's free to do. So you can sign up and download all these files for free. So you can go back here, and for the waste we have 8 different classes, not 8 different classes, 8 different types, not even types, 8 different objects that we want to classify. So we have 4 classes right now. So these are the 4 classes, and these are the 8 types of 8 different types of objects that we have that we want to classify. So we have can, we have business, not business, it's newspaper, we have old shoes, watercolor pen, battery, disinfectant, and vegetable leaf, apple, and that's it. So you can download these images and you can create cards out of this. So as you can see here, we have these cards. So this is for watercolor pen. So it's not focusing, so you have to bear with me. And then we have the business news, then Apple. So all of these are printed and they are on a card. You can print it on an A4 paper and work with that as well if you don't have this card material. Now this actually came with a game. I bought a game for kids, and this is a very good way to introduce kids to the concept of recycling and waste material, classifying it. So you have these bins, they provide these bins, and they have the same 4 categories. So you have residual, hazardous. So these are very small. And in future, what I want to do is, right now I'm traveling, so I don't have access to all the motors and Arduino and all that. So what we can do is we can attach servo motor at the back, and it opens up the correct one. So all of these, they can stack up next to each other, and then the one that is of the relevant class should open up. Now this is green in color, but it will not show up because I have a green screen at the back, so it will not show. And then here we have blue. So this one is recyclable material. So all of these are different baskets that you can have, and you can automate this process. That will be really interesting to see, and I want to do that as well. So hopefully in near future I will automate this process. So these cards were also available within this game, and they had lots of them. So I guess maybe close to 100. I can't seem to find more, but these are some of the others. Oh, I found them. So here you can see there's a lot of them, these cards. So you can create your own cards using Canva or some other software free to use, and you can download and use them as these cards. But these cards, again, they are available on our website. You can download and print them as well if you want to do that. And it is good to see the exact same picture when the classification is done. So when it classifies, if you see the exact same picture, for example, if it classifies an apple and you see the exact same picture like this, it's more pleasing to the eye. It looks better. So that's the idea. So here we have the waste images. Here we have the bins, and here we will create the model. So the model that has the classification in it. So that will help us classify. So this is using Keras. Keras is a library that is used with TensorFlow. It's a higher level library that was first built by itself. Not by itself, it was built separate to TensorFlow, but then it was embedded together and now it comes with TensorFlow. So when you're installing, you just have to install TensorFlow and it works. And these are the labels. So the first one will be nothing, then the can, newspaper, all shoes, all these 8 categories are here. And one of them is 0, which is nothing. So that's the main idea. And what we are going to do, we are going to create this model. We are not just going to use this as it is. I will teach you how to do that. And then we have an arrow, which is just there for the design purposes. So this is what we have. Again, you can download this from our website. It's free to use. So let's go ahead and add our classifier. So from cvzone dot classification module, we will write import classifier. So that's the idea. And let's just see if this works. And how we can confirm this is by just running it and looking for any errors. So hopefully, fingers crossed, there are no errors. Okay, there's a problem with namespace. Okay, so for now, let's just continue. I don't think we have any issue with the TensorFlow, but let's see. So what we can do is for our library cvzone, we have some testing code as well. So what you can do is you can click on the control button, and you can press the control button and you can click on your mouse and it will take you to the class. Now within the class you will find a function called main, and within that main you will see the example code. So here you can see we have the capture, video capture, then we have the classifier, and then we have while true, and this will give us the webcam feed. So let's just copy all of this and we are going to paste it here. There you go. And we can remove this capture. Okay, so for now we don't have the classifier. We didn't create any classifier, so we are going to remove these 3 lines. We are going to comment them. If you don't know how to, you can press Control and backslash to comment all together. So these 3 lines we have commented. So what we are doing is we are saying import the video capture device and then read from the frame and then show it on a window called image and then wait for 1 millisecond. So that's what we are doing so far. And one more thing we have to do, I have multiple cameras attached, so I'm going to use camera number 2, I believe. I think that's the one. Let me just make sure it's on. Yeah, it's on. So what I've done is I have a camera attached pointing downwards and it is looking at a box, and on top of the box we are going to put all the cards. So it's a very simple setup, nothing fancy. Okay, so let's run this and see if it works. And there you go. So now we can see the image, and I have added a tape here so that we know where exactly we want to put the card, so you can place it like this so it's nice and tidy. So that's the main idea. So we can put all these cards like that. Actually we can turn it around like this, and there you go. So this can be turned into a very good game for kids, so for teaching them, or you can automate the process. It will be really nice to see. Okay, so that's the basic idea. And the second thing is to create your model classifier. So it should be able to classify all these different types. So now we have the camera ready and we have the setup ready, so we can go to our classification part. So here we are in our teachable machine, which is provided by Google, and we are going to create our classification model here. So we are going to click on the image project and we are going to go with the standard image model, and here we have different classes. So the first one we are going to add is nothing. So nothing will have all the images of nothing actually. So when we don't have anything on the box. So here we are going to click on the webcam and we are going to switch the webcam to my webcam, the one that I'm using for detections. And what we will do is we are going to start with nothing. So what I will do is I will move the box a little bit so that it's not just still the images. We are getting different types of images like this. I'm going to move it, but not too much, because this will be stable and it will not be movable, so I don't expect it to move. That's why we are not going to move it too much. So we are going to hold the button and we will keep moving, and you can see we are capturing images. For each image, for each type, we are going to capture almost 100 images. It doesn't have to be exactly 100, but close enough would be good. So here we have 120, so which is good. The next one, we are going to start with recyclable materials, and those are the can and the newspaper. So let's go ahead and we are going to put the zip top cans. So we are going to write exactly the same name. So this will be zip dash top and cans. So we'll open the webcam. Okay, let's try it here. We do have the permission. Okay, let's go to the webcam, and here is the camera USB device. No, we are not trying to access USB device. That's why it's giving an error. What we are trying to access is this virtual camera. So that's why we had this issue. Oh, we cannot reload. You have to click here. So here we are going to hold and we are going to move it a little bit, not too much, just a little bit, and there you go. So you can also invert it, you can flip it and then take the images, but I don't think we need that for this case. Okay, so that's it. We are going to close this, and then we are going to add the third class, which will be newspaper, and we will open up our webcam. We will remove the ones we have done, and then we will go for the newspaper. Same process. We are going to move a little bit until we get about 100 images, and there you go. Now we have for the newspaper. Now this process takes a while, but it's not that bad. Newspaper, then we have old shoes. There you go, 100 images. And then we are going to add another class. This is watercolor pen. Watercolor pen. Let's add the webcam. There you go. Hold, move. There you go. Then we add another class, which is disinfectant. Are the spellings correct? No, they are not. Let's just use that. Webcam, is it moving? Yes. Okay, let's hold to record. There you go. And then we'll go to the next class, which is battery. So the thing is that this is a good idea and we don't need a lot of samples because we are working in a controlled environment. And what that means is that we don't have a lot of different cases, especially with the background. So the background is pretty stable. It's going to keep the same. So we are going to have the same background each time. So it will be easier for it to detect. So that's why we don't need a lot of samples, and we can just move it around a little bit and that should be enough. Vegetable leaf, and now we are at the last one, which is apple. Okay, so let's record that. There you go. So we have about 100 for each one of them: 126, 110, 127, 132, 114, 120, 118, and 120. So that's the main idea. And what we can do now is we can train the model. So the training is not going to take a long time, so we can just wait for it to finish and then we can continue. But make sure to do not close the window, just wait for it to finish. It might get stuck, that's okay. Just wait for the process to finish and you should be good to go. So now you can see that the model has been trained and we have our first result. So if we have nothing, it shows nothing. We put the apple, it shows an apple. Vegetable leaf, there you go. Then we have the battery, it shows 100% battery. Disinfectant, watercolor, old shoes, newspaper, and the can. I think the webcam stopped. Let's try that again. There you go, Zippo can. And if we remove, there you go, then we have the zip top can. So these are all the 8 different types of objects that we are going to classify, and each one of these will belong to one of the categories that we have. And how do we classify them? It's very simple. We are going to use a little bit of Python code to differentiate the different types of our waste materials. So here we are going to export model, and we are going to click on TensorFlow, and we are going to keep the Keras model, and we are going to click on download the model. Now you don't have to worry about all of this code. We are going to have our own code. We will write it in our own way, which will be easier to actually work with. So here we are going to wait a little bit, and it might take some time if you have a lot of different classes. If it's just a few, it should be quick. So here we have the Keras converted. So we are going to copy both of them, right click and copy, and then we are going to go to our folder in the model and we are going to paste it there. Replace the files in the destinations, because that was the testing one I did earlier. So this is the new one that we just did right now. So let's just close that. We'll close this, and we don't really need this. We can turn off the camera, but we will keep it on just in case we want to change something, add something, and train it again, because we don't want to create all the classes again and all of that. So that's the idea. And then we are going to minimize it, and here now we can classify it. So let's just open it up. So here it says mask classifier, so we can just write classifier instead of mask. And here we can write classifier again, and we can remove the comment, and it will show us the prediction. So right now it says model Keras model.h5 and model labels.text. That is not true because we have it in resources. So it's in resources, then model, and then Keras. So here we have to add resources, and the same thing we have to do over here. So now it should work. So let's run that and see if we are getting our classes. So this is how simple it is. We have the classification module, the classifier is working. You just have to write classifier.getPrediction and give in the image. So here, as you can see, it shows nothing. If we put the apple, it says apple. If we put the can, it says can. If we put the newspaper, it says newspaper. Old shoes, it says old shoes, and so on. So right now we can see that the classification is working very well, and we have been able to bring this into our Python code, which is very exciting. Now the next step is very simple. What we have to do is we have to bring in a background image. So we will take that background image, and that will be the end results, the final output. So we don't want to show it like this. We don't want to classify it like that. We want to make a game out of it for kids, for understanding, for awareness, whatever the case is, we want that background image. Now, what we can do is we can simply write here, and that background image is here within the resources folder. You can see here waste classifier. So we can simply import it by writing, let's say, image background, and we are going to write cv2.imread, and we want to read from the resources, and within the resources we have our background.png. So that's how simple it is. And what we can do is we can write here, we can copy that, and we can write, let's say we'll call it output, and we will write here image background. So it's going to show both things. So let's run that, and it is a big image. It's 1280 by 720. So hopefully it will work out. And there you go. So here you can see the waste classifier image, and we will also have our webcam image. Now, keeping both of them separate is not a very classy thing to do. So what we will do is we'll take this and we will embed it here, but without these annotations. So we don't want to write that. We are going to add images and all that separately, showing that that is what we are doing. So that's what we will do later on. But one thing to note here is that when you are reading the image outside the while loop, whatever you put on the image will remain there forever. So you cannot remove an image. So for example, if you classified, let's say, old shoes, so next time when the newspaper comes in, you can overlap on it, but you cannot remove the old shoes. So that's not very good. So what we can do is, because if we add an arrow, we want to remove it, or whatever the case is, we should have a plain slate so that we can add images on it in every single iteration. So we will remove this image background import, and we are going to put it within our loop. After, let's say, our image has been read, we are going to import it. So every single frame is going to import it, and it's going to display it, and it will refresh in the next frame. So that's how we can do this. Okay. So once we have that, the second thing we will do, we will add our webcam image onto our, the background image. So that's very simple. All you have to do is you have to squeeze it down first. I have written down the value somewhere, the resize that will fit perfectly within our image. So here, once we get the image, we are going to write image resize, and we are going to use cv2.resize to resize it, and we will give in our image, and we will give in the size. The size should be 454 and 340. So this is the size. We have 640 by 480. We are squeezing it down to 454 and 340. So that's very simple to understand. And then once we have that, before we show it at the end, before the display, let's just put a comment here, displays. So before we display, we are going to add the webcam image onto the background image. So how can you do that? You can take the image background, and you can say that on the specific part of this background image, I want to overlay my image resize. Now, what are those specific parts? We have to define here. So the starting and the ending height, and the starting and the ending width. So the height comes first. So the starting height, again, I have the values. It is 148. That's the starting value. And then the height of our image is 340. But we have to add the initial value, 148 plus 340. So that's the idea. And then we have to do it for the width. For the width is 159, and then 159 plus the width is 454. So that's our width. So now our image should be overlaid on our background image. The webcam image should be overlaid on the background image. So let's have a look at that. Okay, we are getting an error. So, oh, no error. I guess it was the previous one. Anyways, so here we can see now we are getting it within our image. So which is pretty good. Looks really good. I think my webcam sleeps, so we have to turn it on again and again. So here, By the way, I'm using a DSLR camera. That's why it sleeps. So there you go. And it is working well. Let me remove this logo. There you go. Now this looks better. Tilt. A little back, a little back. There you go. I think this is the perfect location. Maybe a little bit forward, backwards. There you go. Yeah, that's perfect. So this is the main idea. And now what we can do, oh, I threw it away. Now what we can do is we can remove the other image. So I am sure we can remove that because we don't want double display. Okay, so that is well and good. That's the first step. The second step is to import all the images. Now, why do we need all the images? Because we want to display it. So which images do we need to import? So we need to import all the bins, and we need to import all the waste images. So all of these images we need to import because we are going to display them. So importing is very simple. All you have to do, let's write here, import all the waste images. So here let's create a list, and we are going to call this list image waste list. So what exactly is this list? It will contain all the 8 images. So here we have 8 different images. It will contain, we are going to import it. We are going to use CV imread, and then we are going to put it in this list. So whenever we want the image, we can just tell it image waste list at number 1, give us the image. At number 3, we want the image. So that's how we are going to use that. But to actually get the images, we don't want to hard code it that, okay, we have 1 image, so bring in that, we have 2nd image, bring in that. What we are going to do, we are going to get the list of all the images we have, and then we are going to import them one by one. So if we had 10 images, we had 20, it will import all of them automatically. So how can we do that? We can do that by using OS. This is the library, os.list directory. And what directory are we using? We are going to write path of the folder of the waste, right? So that is resources slash waste. So this is, we are going to use this later on as well. That's why we are putting it in a variable. Otherwise you can just copy this and paste it here. But because we are using it multiple times, it's better to put it in a variable. And then we are going to put this in a variable as well. Let's call that path list, not lost list. And now we have the list of all the paths. So let's just print it out to see if we are heading in the right direction, and then we can continue. So let's see, what do we get in the path list? So this will happen only once in the beginning of the code. So here you can see we have the list of all the images. So 1.png, 2.png, 3.png, but this is just the text. It is the name of the image. It is not the actual image. So what we need to do is we need to import these actual images using these names, and then we can put it in our image waste list. Might seem complicated, but it's very simple. We are going to say for path in the path list, we are going to write, we want to import cv2.imread. We are going to read the image, which is the file name. For the file name, we have to join the path like this, ///. Another way to do this is using os.path.join. So what path do we want to join? We want to join resources/waste plus 1.png. So when you get that, it will be complete path. So we want to add path folder waste, and we want to add the current path. So that will give us the actual path. And one very important thing we have to note is that these are PNG images and they have rounded edges. The corners are rounded. So if you want to use that functionality, if you want it to look nice, what you have to do is you have to get the alpha channel as well. So to get this transparency, what we have to do is we have to write here cv2.imread unchanged. So don't change anything, don't convert anything, just bring it in, and we are going to use the alpha channel if it's available. So that's the idea. And then once we have that, we have to put it in the image waste list. So we are going to write image waste list dot append, and then we are going to put this bracket. Okay, so whatever image we are importing, it will just keep going in that. Why am I writing wrong? Append. Okay, so that is good. And now just to test if it works well or not, what we can do is we can add a dummy image. We can just pick the first image and we can put it on our main image. So here what we can write is now to import a PNG image, to overlay it, we have a function in CVZone. So we'll write CVZone dot overlay image, overlay PNG image, and then we have to give in the background image, which is image background, and then we have to give in the front image, which will be, let's say, image list waste list at number 0. That will be the first image, and then we have to give in the position. So the position I have checked already, and the position for waste is 909 and 909 and 127. So that's the idea. So and we have to put it back in the image background. So image background equals this. So let's rerun it and see if it works. So right now it's just a static image, the first one, and later on we are going to add it based on the prediction. So whatever prediction we get, we are going to add that. So there you go. It shows here zip top cans, and it looks really good. So now based on the prediction, we are going to check which image to add and which image to remove. There we go. So if we put this, it should show us zip top cans. If we put, let's say, newspaper, it should have the newspaper image. So that's the idea. Okay, so how can we do that? Now, the way to do this is over here, you have a static image, a static variable. So what you need to do is you need to make it dynamic. You need to make it changing based on the prediction that we're getting. The spelling for prediction are wrong. Show context, type prediction. Okay, so here, first of all, we need to see what we are getting inside prediction. So whenever you see it's printing here, all these predictions, so you can see here, these are the probability values. So we have 8 classes, so it's showing the probability of all the 8 classes. And you can see it's giving us another value at the end, which is the class number. So that is what we are interested in. So we need the class number right now. So this is our first variable, which is a list, and this is our second variable. So if we call number 0, we will get the first list, and if we call number 1, we are going to get this figure. So that's what we want. So let's call it class ID equals prediction at 0, not at 0, at 1. So this is what we are trying to get. And if that is available, if the prediction is there, then we are going to overlay. Otherwise, we don't need to add any image. And which image do we add? We add the class ID. So then we have to change this. We are going to use our ID to get the image value. So here, instead of 0, what we need to put is the class ID. But as you know, the class ID starts from 0 and it has nothing. So there is no image for nothing. So we need to start from -1. So class ID -1, and then it will align with our other list. Okay, so let's run that and see if it works. So right now there is no prediction, so there should be no image. So there you go. So there is no prediction, but there is an image, which is not good. But let's just put a newspaper There you go. We get the newspaper. We put old shoes, we get old shoes. We put apple, we get apple. We put color pen, we get color pen. But why is it not removing? It's always showing apple. So what happens is, even if there is no new prediction, there was an old prediction. So what you can do is, you can write that every time prediction equals none. None. There you go. I think that should solve the problem. Or no. Actually, that's not the problem. The problem is that even when there is nothing, the prediction has the value 0 in it, because when it's nothing, the ID class number is 0. So what we have to do here, we have to write not equals 0. If prediction is not equal to 0, then only do all of the below. So that's the idea. Let's see if it works. So there should not be any image right now, apple or whatever the case is, but there is still. So there's still an apple there. Why is that happening? Oh, my bad. I got it. So this, it should not be prediction, it should be class ID. So if class ID is not equals 0, because prediction is the whole thing, it should be class ID. That was the issue, hopefully. And I think we can remove that. Yeah. So there you go. If we put something in and if we remove, there you go, it works. And I don't think, just put it straight, I don't think, I guess there's an error. What's going on? The battery, either not trained properly or disinfectants is showing battery. Okay, so I guess we are doing something wrong. Let's check that out. So zip is fine. Apple is giving vegetable. Okay, so our values are wrong. Oh, okay, I think our sequence is wrong. So the sequence of these images and the sequence at which we put these labels should be the same. So here, let's check that out. Okay, so zip is number 1, then we have newspaper, the third is old shoes, the fourth is watercolor pen, then you see that's the issue. Here we have disinfectant and here we have battery. So this is opposite. And then we have vegetable and apple. So apple is at the last. Yeah. So that's the problem. So here we are going to write 5, 6. And here we are going to write 5. And here we are going to write 6. So let's check that out again and see if it works. There you go, disinfectant. We put the battery, we get the battery. We put the apple and we get apple. We put the vegetable, we get the vegetable. There you go. So that's the idea and it is working well. Now where did we leave? So now the images are there. We can also add the arrow. So we can write here that we want to import the arrow. So image arrow equals cv2.im read, and we want to read from the resources / arrow.png, and it should be cv2.unchanged img, not umg, img underscore what was it? I am read, sorry, I am read unchanged. So that's the idea, and then we will use the image arrow to add. So similar to this, we are going to copy that and we are going to paste it here, and then here we are going to simply write image. Yeah, we are going to overlay it on image background, and then we have to put here the image arrow, and the position, let me check, it is 9, 9, 7, 8 and 320. We can remove this, should work fine without that. There you go, and if we put the battery, there you go, it shows the arrow, disinfectant, watercolor pen, works fine. So the next step is to actually get in the different bins. So we need to classify which material does it belong to, which type of waste it is, and then based on that we need to bring in the bin. So that's the main part. So to classify it, the first classification we have done what type of object it is, and then the second classification is what type of waste it is from the 4 categories that we have. And that one we can pretty much do it in Python. We don't have to create another model for that. We can simply do it with simple coding. So now we are going to add the bins. So the process is pretty much similar to adding the waste. So we are going to import the bin images first, and we'll put it in a list. So here image waste list will become image bins list, and path folder waste will become path folder bins, and we will write here bins. Then path list is list directory path folder bins, and over here as well. And then we have to change image bin list. So we will take one of these images and we are going to put it right away. So let's just take this as an example. We paste it here and we will use image bin list, and we are going to put value number 0. So the first image that we have, and the placement, again we have the values for it. It is 8, 895 and 374, and this I want to keep it even when we don't have any detections. So whatever the bin is, just keep it there, and when we have a new detection we can change the type, but we want to show it all the time. So bin list at 0. We are going to use a dynamic value later on, but for now let's just keep it like this. So this will show us the bin. There you go. So we have our recyclable bin, and when we add something it will show like this, that it goes in there. But whenever we add this, we have to change the bin type. So here we have to define which bin corresponds to which object. So this you have to do it manually, and then the software will pick it up and do it automatically, classify for you. So here we are going to write let's say class dictionary. In this dictionary we are going to write which image corresponds to which class. So this you have to do a little bit of matching. So for example, this ID1, so this is number 1, will match with bin number 1. Let's say this will be bin number 0, this will be bin number 2, bin number 3, 4. So we have to take these values and we have to match them. So let's just start. We can make this smaller. We can go to our waste, and over here we are going to write, so if we have number 1, then we have zip cans. Now there's also a class 0, so don't forget that. So class 0, we have nothing, so it responds to none. Then we have class number 1, which is zip top cans. When we have this, the bin will be recyclable. So here we are going to write bin number 0. So that's our first one. So what we can do is we can write it here that bin number 0 is recyclable. Then number 2 is hazardous. Then number 3, number 2 is food waste. Let's just put it like this. All of them are waste, so we just put food. And number 4, or the ID number 3, is residual. So that's the idea. So here now we can go back to our waste, and the first one is recyclable, so we are writing that. Then the second one, so here the second one is recyclable as well, so we'll put it again as 0. Then we have number 3, number 4, number 5, and we need to put the commas as well, number 6, number 7, and number 8. So here we are going to put the values. So this number 3, it is residual, so we are going to put here ID number 3, and number 4 is also residual, so we are going to put 3. Disinfectant is hazardous, so we have to put 1 and then 1. And then battery and vegetable and apple, they are for the food, which is 2, so we put here 2 and 2. Then we can just reformat it so that it comes in one line. So these are the ID numbers that we are going to use, and once we have this dictionary value, we are just going to check which value does this correspond to, and we will take that image from there. So it's very simple to do that. So let's just open it up, and here when we are getting, this is where we have to add. So whenever we are getting something, so the class ID is exactly as we want, so we are going to check from the class dictionary, we are going to add the class ID, and that will give us a number. That number basically corresponds to the image within our image bin list. So we will take that and we'll put it in image bin list, and that will give us the actual image. So we can, or should we put it here? Let's just call it something. Let's call it this ID number. Let's call it class ID for the bin. So class ID bin, we are going to put it here. And this class ID bin, we have to define it outside as well. Once in the beginning, we'll put it at 0. So it starts from somewhere because it has to show an image before it can start. So let's just run that and see if it works. So there you go. All shoes are residual waste. Then let's check the disinfectant. It's hazardous. Let's check the apple. It is food. Okay, apple, we might need to add a little more images for training. Battery works fine. Newspaper, recyclable waste. Then we have watercolor. residual waste. So there you go. So now we have pretty much a game, and it's something that is interactive. It is good for learning. That for example, you show it to the kids, you tell them put it there, and you can also automate it, which will be really amazing to see. That if you put this there and the hazardous waste opens up, and then let's say you put old shoes and the residual waste opens up. So this will be very interesting to see how you can embed this with Arduino. By the way, we have a course on Arduino and computer vision. If you understand the concepts there, you can pretty much do this classifier project with the servo motors and Arduino, and that will be a really good project to see. I have not seen that yet with 4 different boxes or classifiers, but for 1 or 2 I think I've seen somewhere. So that's the idea. It's very simple. Are we missing anything? I don't think we are missing anything, because pretty much everything is there and we are able to run the code, and you can add your own classes, you can add your own objects, and we have a lot of other objects as well. There's a lot of them that they provided, as you can see here. So we can add these as well one by one, but it will take a while. So if it's really your project, then go ahead and do it. If you're just learning for learning, then I think 2 for each is good enough. So that's it for today. I hope you have learned something new. If you liked the video, give it a thumbs up. If you loved it, share it with your friends, and I will see you in the next one.